All right, number 35, solve the problem. We're told the sum of a student's 3 scores is 216. If the first is 10 points more than the second, and the sum of the first 2 is 18 more than twice the third, what was the first score? And so what we're going to do with number 25 is come up with a system of equations. We're going to come up with 3 equations for number 35 and then solve the system. And this is not unlike questions 27, 28, 29, and 30, where you were given 3 equations, 3 unknowns, and asked to solve. This time we are having to come up with the system ourselves as opposed to being given the system directly. All right, so let's see what we can do here. So the first sentence here, the sum of a student's 3 scores is 216. So let's come up with equation 1. And if the sum of a student's 3 scores is 216, we can let score 1 be indicated by A plus B, which will indicate score 2, and then plus C, which will indicate score 3. And the sum of these 3 scores, we're told, is 216. All right, and the second sentence here, or at least the first half of the second sentence, tells us if the first is 10 points more than the second, all right, so equation 2, if the first, and recall we're letting the first score be represented by A, so if the first is 10 points more than the second, 10 points more than the second, all right, so we don't know what the second score is. All we know is that 10 points more than the second, and again, we're letting the second score be represented by B. So 10 points more than the second is what the first score is. So there's equation 2. And then finally, the third equation we'll get from the second half of the second sentence, where we're told the sum of the first 2, so the sum of the first 2, A plus B, is 18 more than twice the third. So twice the third plus 18. This is 18 more than twice the third. And again, we're letting the third score be represented by C. All right, so here we have a system of 3 equations, 3 unknowns. And let's go ahead and, before we start actually solving, let's get all of the variables for each of these equations on the left-hand side. All right, notice equation 1 is good to go. We've got our A, B, and C on the left, the constant on the right. So that's what we want. Here in the second equation, let's go ahead and get the A and the B on the left and keep the 10, that constant, on the right. And so what we'll end up with is A minus B equals 10. And then here with equation 3, again, let's get A, B, and C on one side of the equation and the constant on the other. So we'll have A plus B minus 2C equals 18. All right, so we'll let this be our new equation 2 and this be our new equation 3. And so what I'm going to do is, so we don't confuse ourselves, I'm going to get rid of the equation 2 and equation 3 that we started with, and we'll bring these 2 new equations that we rearranged over. All right, now let's look at this. Now this looks very similar to, again, 27, 28, 29, and 30. And we can see here that equation 2 does not have variable C, right? This only has variables A and B. And because equation 2 is missing, does not have a C variable, that makes our job a little easier. And what we're going to do is let's start off by eliminating the C variable from equations 1 and 3. And so to start off, I'm going to go ahead and rewrite equation 1 up here. A plus B plus C equals 216. And below it, I'll write equation 3. So A plus B minus 2C equals 18. And again, because equation 2 does not have a C variable, let's eliminate the C from equations 1 and 3. And we know that to eliminate a variable, we need the coefficient of that variable to be additive inverses. So if we have a positive C here and a negative C here, let's go ahead and multiply this top equation by 2. And what that'll do for us is 2 times A is 2A, 2 times B is 2B, 2 times C is 2c. And lastly, 2 times 216 gives us 432. And now we can go ahead and add. So a plus 2a is 3a. B plus 2b is 3b. The c's go away. And now we're left with 18 plus 432 gives us 450. And now this new equation that we've just come up with, let's go ahead and label that equation 4. And notice again that equation 4 that we just came up with only has variable a and b, and just like equation 2 only has variable a and variable b. So using equation 2 and 4, let's go ahead and eliminate the b variable, because remember, we're trying to solve for the first score. What was the first score? So ultimately we want to solve for a. That's what we're trying to do here. So if we use equation 2 and equation 3, we can go ahead and eliminate b, which will allow us to solve for a. So let's take equation 2, write it underneath. So we have a minus b equals 10. And what I'm going to do is I'm going to create some distance for us. So I'm going to just move this down just a little bit so that we can have some separation and see what we're doing. All right, if we want to get rid of the b variable, again, we need additive inverses for these coefficients here. So we have a positive 3, which means we need to have a negative 3 here. And we can get that negative 3 by multiplying by 3. So 3 times a gives us 3a. 3 times negative b gives us negative 3b. 3 times 10 gives us 30. And now that we've multiplied by 3, I'm going to go ahead and eliminate, get rid of that whole equation. Oops. And then I will move this up so they're stacked. And now we can go ahead and add. So 3a plus 3a gives us 6a. The b's go away. And 450 plus 30 gives us 480. And if we want to solve for a, we'll divide by 6 on both sides. And that'll give us a equals 80. All right, and so there we have it. A equals 80. And again, recall that a represented the first score of this student's 3 scores. And so ultimately, we've solved for number 35 because they asked us what was the first score. So we were looking to solve for a. We did that. The first score is 80. But just for extra practice, let's go ahead and quickly solve for scores b and c. It won't hurt. It won't take very long. But 35, the answer is 80. That first score was 80. But now that we have this first score, if we want to solve for b, what we can do is we can take this score and plug it into equation 2 for a. All right, and let's do that. So we're saying a minus b equals 10, but we know what a is. We just solved. So 80 minus b equals 10. We want to solve for b, so let's subtract 80 from both sides. That'll leave us with negative b equals negative 70. If we divide by negative 1 on both sides, we'll end up with b equals 70. So score b, or the second score, was a 70. All right, and now that we've got a and b, we can go ahead and easily solve for c. We'll do that here, give us some room. So we have a, which is 80. We just solved for b, which is 70. We want to solve for c, equals 216. So let's go ahead. 80 plus 70 is 150, plus c equals 216. If we quickly subtract 150 from both sides, that'll give us c equals 66. All right, so there are all 3 scores, A, B, and C. A was the first score, which is what we were trying to solve for here in number 35. So this is the actual answer. A equals 80, or the first score was 80, but it wasn't too much more work to go ahead and solve for the remaining 2 scores. So score 2 was 70, and score 3 was 66. All right, there's number 35. I'll see you at number 36.